right, hopefully you can hear me okay. Yeah, good. All right, thanks everyone for coming out this morning. We've got a very interesting set of people, extremely interesting topic to discuss. So I think it's best if we just, first of all, if you could just give your names, where you're from, and introduce you to the audience. So,
I'm Yuda, and currently I'm a doctoral student at ETH Zurich, and currently I'm a member of the development team of HyperOracle. We're working on ZK oracles and generating automatically proof instance. Thank you.
Yeah.
Hi, my name is Wei Jie. I'm at Geometry, and I'm on the research team as a research associate. Previously I was at EF working on applied ZKP, so thanks for having me.
Yeah, hey everyone, my name is Ignacio. I'm a cryptography researcher at Nethermind, and currently I'm focusing on zero-knowledge proofs and their security mainly.
Hey everyone, my name is Artem. I'm part of Aragon research team, focused on ZK. Currently we're building some private voting solutions, but we also look into private DAOs and related topics. So yeah, also a bit interested in ZKML. That's my little side hobby right now.
I'm Amir Taaki from DarkFi, which is an L1 for anonymous engineering. We have our testnet released now, which has generalizable, programmable, anonymous smart contracts.
All right. Thank you, panel. All right. So I'd just like to start off, if you could just think about, the last 6 months, a year, think of any new application in zero knowledge or new piece of research that's really excited you, that perhaps maybe the people wouldn't know about. So you can go in any order. So anybody who has a... you like to start off? Yeah.
Okay, I mean, it's a big news not only for our community, it's actually for the order what people are paying more attention on, let's say, artificial general intelligence and large language models. So how to remain the confidentiality of the user data when during the inference time, I mean, it's really important right now because due to the GDPR protection or such kind of violations always happens. So, I mean, particularly we can talk something about maybe ZKML. So how do we use ZK as utilization to protect our user data? And what is the situation of it? I'm quite interested in that.
Yeah. I'll certainly come back to ZKML in a second. Yeah.
I guess for the past 6 months and even past 1 or 2 years, we've seen a lot of focus and development on, I think, scaling solutions. And I think the technology and the fundamental approaches that teams have been doing have been around, for example, recursion or around ZK VMs. They're using different techniques. And all this has been focused on trying to scale blockchains and trying to scale Ethereum on L2. And I think a lot of interesting teams have started to use these building blocks and build things beyond scaling, such as identity and even ZKML. So I think that's very interesting. And I think there's so much has happened in the last 6 months to the last 1 year. It's very hard to keep up. I think, yeah, so there has definitely been a flurry of activity in these areas.
Great, thank you.
Yeah, actually, it's kind of funny. I was kind of a mix of both previous answers, in the sense that very interesting application of ZKML, kind of at the intersection of the validity proof of like a certain computation, the privacy preservation of the data, and also the heuristic optimization of machine learning. And one application I was particularly interested in as well is in identity management, actually, and things like ZK credentials and those type of things.
Yeah, it looks like ZKML is the hot topic right now. I guess the reason for that is we just learned about what are the capabilities of big language models about half a year ago, so it's perfect timing for the question. And actually, I already know that, well, for me, part of the problem is that we also need to prove that we did inference correctly to put the model on chain, for example. And right now, the big businesses are making big decisions based on the outputs of these models. So proving that the model was run correctly is quite important. And actually, know there is an effort for doing this with GPT-2 by Daniel Kahn. So yeah, I'm very, very interested where this goes. in the future.
Thank you.
There's a common trope in sci-fi, which is contact with an alien civilization. For example, in The Expanse, when they first discovered the ring. And all of this crypto tech, which is coming out now, is honed powerful techniques that is opened up an expanse, which we're only just beginning to peek through the door or scratch on the surface. And there are so many things that we want to make that is really crazy. Like, obviously, there's stuff around markets and building anonymous digital marketplaces. But we also made the world's first fully anonymous DAO, anonymous on-chain treasury, anonymous voting, all the participants anonymous. And that was from our experience with Assange DAO, where we raised 55 million to free Assange by all means necessary. But then it was like a public on-chain treasury where all the participants were public for a political prisoner. So it really just didn't make sense in a transparent context. And then second of all, we were like bidding in a auction, and everybody could see our treasury. And the fact that everybody could see it meant that nobody would bid against us. And it just completely broke the game theory of that auction. So anonymity really expands the design space of financial engineering. And there's even other stuff like online marketplaces, which are completely anonymous, where you can buy and sell anything, where you can exchange crypto, where you can like local bitcoins, completely anonymous. Like all of the crypto infrastructure we should be building peer-to-peer and anonymous. Also, there's a load of privacy projects going, oh, we're building privacy tech, but they're on Discord, and they go, oh, link your social media to like authenticate. And it's like, what? Like, how are we going to like really deliver the true promise of crypto when we're not actually building the self-sovereign infrastructure and consuming our own dog food? So we made our own anonymous chat. It's the most anonymous chat on the market. There's nothing that exists like it. All the messages are unlinkable. There's no identity. Like, not even Signal or anything else comes close. We made an anonymous task management system, and we're going to migrate away from GitHub. So we move into a fully anonymous peer-to-peer paradigm. And also, another really cool topic is information marketplaces. Like, you can make a marketplace where people can buy and sell information. Like, oh, you have Hollywood movie or secret document, and somebody says, oh, this document's this thing. And you go like, okay, prove it. And then you can have a protocol where a certain random portion of the file gets decrypted, and then it authenticates the claim of what that info is. And then everyone bids in an auction, and the person that bids on it gets the decryption key. And then essentially, you've just destroyed the business model around secrecy for corporations and trade secrets. So it's just so exciting. Like, there's so much to explore. Like, and we need as crypto to like organize and mobilize and work towards that goal, because this is a major historic invention, like on par with the printing press or gunpowder. It literally renders
Can I move this on a little bit, Amir? Sorry, can we move on? I think we've sort of covered that quite well now. So I'd like to go on to the ZKML side of things, because if you want to get all your buzzwords lined up now, you're going to do zero knowledge and machine learning. Now, obviously, there are problems with this. So doing the inference part, the ZK can do this, but things like back propagation, as far as I know, this is not really feasible. But I saw a recent a thing at the ZK Summit where they were doing weightless neural networks, and this was a this seems to be promising, but I don't know enough about this to judge this. So Artem, can you give us some insight onto that?
I guess I'll give a bit of background. So I was part of the Zero Gravity team on ZK Hack, the winning solution. And what we did, we tried to reimagine how neural networks work. So instead of trying to fit in neural networks into ZK by doing some truncations of the weights, because right now, so that you understand, neural networks work using floating point arithmetics. And what we use in ZK is more field arithmetics. We just don't really work together. There are ways around it, but they lose efficiency and they lose precision. So essentially, you get worse models after doing that, and it's very hard to do it. So we tried to reimagine the solution by essentially going away from floating point arithmetic altogether and using one of the previously proposed solutions of weightless neural networks, where you use lookups to optimize how they work. That's what we built. It worked on NIST, but we had about 2 days to make it happen. And right now, actually, there might be future work with the Ethereum Foundation on that, but I cannot say much on how this will develop. But also, in general, what people don't understand is that it's not enough to prove inference. Actually, you need to prove the whole training process, because it has been shown that an adversary can always corrupt the machine learning network from inside when they train it, so that they can always control what it outputs. So it's actually a very big problem for the space, that essentially you need to prove that GPT was trained correctly, and it's already hard to train GPT like that. Imagine how hard is it to prove it. So yeah.
Okay. Sorry, go on. Yeah.
So I also want to put some remarks here. So everything you mentioned here is like proving something is like training correctly. Like it is like a trade-off. Sacrifice your utilities for some preservation of the confidentiality or correctness. And most often, and in the other occasions, when we talk about ZKML, we care about the inference, right? So imagine you're talking with the chat GPTs. You want him to compose some letters for you, but actually you don't want to really reveal what you want to him. So actually what we get here is like, okay, inference this correctly, but do not reveal my information. Mm-hmm. So actually this is a little bit different from proving, okay, this inference is correct, because if in that case you can like employ this, you see, corrected output as your witness, something information knows to you. But actually, and this is the case in most of the ZKML applications like EZKL and such kind of stuff. But the question is like, first, if you really want to inference something, and output space is really huge, and you cannot do any heuristic optimization inside it, and it will be questioning that which statement you want to prove, right? And another question is that I need to mention is about the feasibilities. I do not know too much about the training time, but for inference time, if we cannot do prove for more than 10 million parameters and the same level of blobs, actually it's not a big model, right, in today's view. But it would take like maybe more than 10 minutes to do so, and which is not affordable really in practice. So that's we're gonna figure out maybe in the futures, with joint designs, both from the lower level architectures, operators, and the algorithms and the design as higher level. Mm-hmm. So that's all.
And maybe just to add a bit more, like this is another way to think, and the third way is to add fully harmonic encryption and say that what about we want to prove my, do inference on my private data without the other person knowing what I'm actually doing inference on, but they have the model, so that's like a third level of complexity. Mm-hmm. And I think this is one of the hardest problems to solve right now.
Yeah.
So that brings me kind of to a more general point, perhaps, in that what are the potential bottlenecks at the moment? Is there any particular things in zero knowledge that you think, well, only if we could, this particular hash function was quicker or something like that, if only we could solve that, then the whole area would open up? What do you think? Ignacio, would you like to, is there anything you can?
Maybe one remark regarding the last point. Yeah. I think something that was quite surprising to me is that many times people, because of this GPT kind of concerns about like using your information when they're doing the inference, people focus on the fact that you can render your input data private. I think what's really interesting is that sometimes in some applications you need your model to be private. Mm-hmm. And you don't care so much what the input is going to be, but you do care that people cannot know the kind of models or the weights that you're using. For example, one example I have in mind is you want to detect symbols in some network, for example, and you've figured out some heuristic way to do it, But if you tell people that's the model we're using, then they will go out their way and kind of evade that model. So that's a cool application that I want to talk about as well.
Jay, do you want to?
Yeah, something that I'm personally quite excited about and hopeful for is for developments in hardware, especially if hardware that accelerates ZK-proof generation can be on personal devices, as well as like algorithms that can improve performance. I think generally speaking, if you want to have privacy for users, you want to own your own hardware, you want to own your own data, and therefore you want to be able to generate proofs locally. And if you outsource that, there's always a risk of information leakage and loss of privacy. So I think I'll be very personally excited to see developments in this area.
Okay. So just to go on to that point, I mean, hardware, to get sort of having memory on hardware and this kind of thing and caching, it's as far as I understand it, it's very expensive. Are we at a situation where, the proof sizes and things like that are small enough that it's not going to be too expensive to do all this, or what is the current state of this at the moment? Does anyone have an idea?
I don't have too much information about hardware, but I do want to talk about some roadmaps for the algorithm, or like generating a really zero knowledge proofs. I think typically we have if we have a algorithm, some kind of accepting some language, and we want to generate proof circuits for that. And a general way to do that is that, okay, so first we translate it into arithmetic circuits. And based on this very basic pieces of gates of the circuits of what is, we call it the witness and instance, we kind of generate a very basic system for that. This is only one typical roadmap. And for the other, we kind of employ the terminology called ZK virtual machines. In this sense, we gonna propose portable, maybe virtual machines or compatible programs that we can understand what we are coding about. It's not truly understand, but actually it's just take our natural programming language, such as C++ or Rust, that kind of stuff, as the input and to generating the proof circuits. But the question is that the drawbacks here is that they bypass the procedure of, okay, we really design what is basic arithmetic circuit, so it will generate many maybe redundant or very in terms of nested indexing, it will requires more computational powers and more larger size of circuits to do so. So, I mean, the questions here is that first, should we figure out maybe a new, we see end-to-end ways to generate such proof circuits? Because a very interesting efforts recently I see is from the EasyKL. They do generate the proof circuits not from the programming language, not from the really basic circuits, from these operators in Onyx.
Sorry, who? You mentioned someone who?
Who?
Yeah, which?
EasyKL.
Ezekiel.
Ezekiel, yeah.
EZKL.
Ah, okay.
Yeah. Yeah, they generate the proof circuits from the Onyx, which is some learning architecture like Cafe or PyTorch, and so that's a good idea. Maybe we can not only do on the very basic level, we can maybe, let's say in learning we do everything on the tensor level, right? Can we do something on this kind of concepts? Instead of focusing on the very fundamental gauges.
Okay. What do people think? Is it?
Well, I think, we're seeing a lot of different crypto techniques. So I think the destination that we're going towards is rather than a general, for example, ZK proving system, we're going to have very specialized pieces. And part of that is as well related to two things, which is one is the optimization, where right now a lot of that's done very manually by hand. You predefine or you have like certain gadgets that are like, for example, like lookup tables, a fixed number of rows, and it's very difficult. So yeah, it's very difficult because you have to like rearrange all this data, and because it's not dynamic, it's like hard coded. You can't have it where the entire tooling is intelligent enough to like generate those tables, for example, that are specific for that proof, so it's optimized. So we're very early in that sense. Like if, for example, you look at GCC, when you use GCC, the reason why it's very good optimizing compilers, there are very many different modules you can load for different architectures, so it would be specialized for different applications. Another thing is abstract operators. Right now we use like mainly addition and multiplication in circuits, and you can predefine gates. But for example, we saw Nova now, which comes from like, I think Spartan and Hyrex, but they added a fold operation. So it would be very interesting when we see, because right now everybody's learned the wrong lesson from history, which is that C is better than Lisp. But that's not the lesson from that history. The lesson is that people preferred C because it more closely matched the underlying systems they are working with. And the systems we're working with are algebraic. So there's like a different paradigm we have to construct rather than trying to create a C-like system. And I see a lot of confusion with people where they're like, oh, so it's computing the value? And I think that's a mistake because we're mixing computation and proving together, and they should be kept separate. And also a very important thing is membership proofs, because a lot of applications, when you start to build them, you see you're doing some kind of statement, which is there is this object, there's in the set of all objects, and this is a commitment to these values, and then there's this value which is in this set, blah blah, and you have a lot of statements like that. So set membership proofs, right now, like for the amount that we're doing, they're not like, well, they are quite expensive, but they're like kind of manageable. But if we could abstract away that cost, potentially the usage of set memberships will become really big. And so we will get these very advanced and interesting circuits. Like, for example, they mentioned the machine learning stuff, which right now there's these big centralized models that are owned by, like these big people. And people are like, okay, well, I'm worried about my privacy by feeding this model. So, like we would like to have like our own models, but where we like pool our power and we compute it collectively. And a big part of that is
on the stud membership, that's really what you've been talking about. You did you just done your talk about the gas efficient thing. Do you want to comment on where we're going with that?
I think I'd like Amir to continue because here on the thread is very interesting.
Yeah, the other part is the set non-membership proofs, which I don't know if this is a solvable problem. It maybe isn't, because there's a result from computer science about Bloom filters, and I think it's called approximate membership query filters or something. But it's basically you can create a set membership proof which is constant, but is it possible to create that proof without having the entire set of data? So and there's a lot of isomorphic problems like related to this domain. Like, for example, like if you get two graphs, can you prove that this graph is contained in another graph? Like, is the union of these graphs have a perfect, well-defined ordering? And if you could do that, you can create like very advanced consensus algorithms that are completely anonymous. So, there's a lot to kind of explore.
Go on, Jed, do you want to pick up on that?
I guess one simple application of set membership proofs is, or one simple development upon set membership proofs is that when you have a private application and you want to be able to comply with being excluded from a certain list of entities that you do not want to be associated with, one application or one development is that you prove that you're in the set, but that also that you're not in that set of entities that you do not want to be part of. So there are a couple of approaches to this. One approach, which has been popularized recently, is that you use Merkle trees. Another approach that I like to see hackers build on is to use KGG commitments, because with KGG commitments, you could simply do elliptic curve subtraction, and then you've obtained the commitment to a set of entities that exclude what you do not want to be part of. So I would like to see, I think as a developer, I would like to see more research and development in this field. Especially because I see a lot of talent coming into ZK, and they're looking for interesting things to build on. And I think just take a look at the work that Andre and I did on Semacock, where we use the KGG complements as the accumulator for the set instead of Merkle trees.
To pick up on this point about the operations we have, what would you like to see in it, as well as additional multiplication? What would we want?
Personally, first I'll pick up about the membership proofs, because actually we're building a voting protocol, and basically that's what you need there. You need to prove membership. But there is, in our particular use case, because we are based on ERC20 and NFTs, we need to prove that a person had NFT at some point of time in Ethereum blockchain. And there I would personally like to see connection between storage proofs that then convert to membership proofs, where you can then efficiently prove that you're a member of a set. This is a cool trick we learned, where you don't need to do all the storage proofs all the time, just convert to a friendly format and then do proofs for that. And I think KCG or vertical trees, the new popular term, would be quite efficient there. As for operations, I find that there are two levels of abstractions. One is when you, for example, program something in Hello 2 or very low-level languages, it's like Circum, where essentially all you get is multiplication and addition and some lookups, if you're lucky. But then right now languages, they're high-level languages, we try to abstract it, and I think they're doing a good enough job of just providing you almost all the tools you want. Something like Noir, and Cairo maybe, and other ones. So I think it's getting better. For developers to jump into.
All right, Ignacio, do you have anything you would like to see in that side? Yeah.
Actually, I think that's the direction we're heading to anyway. When you see, for example, how an arithmetization system like TurboPlonk allows essentially for wild custom gates, I think people have identified that this is what we need in order to solve a range of different applications. And ideally, I would like to see any possible gate. I'd like to see everything being built. In any case, I think we're going in that direction. For sure.
What about modularity? It seems that now we're getting different types of proving systems. Are picking bits of technologies from others. You can pull Fry into Plonk and this sort of thing. Is that the direction we're going in? Should we be looking at that, or should we stay more insular? What are the advantages for that?
Can we talk about disadvantages?
Yeah, sure.
Or potential risks? Because voting is a really good mechanism, but in practice it has variations, implemented in different ways. You may vote by your quantities, but you may vote by your, let's say, stake inside a block of a blockchain. And actually, that's how proof of stake works, right? The moderators assign different verification tasks based on what you're assessed with the stakes. And here comes the problems okay, so what about that malicious users, malicious blogs, malicious nodes that have occupied a certain portion of this block? So that's because when we talk about votings, because we always believe that, okay, so there are some malicious ones, but they are a few. So actually we can believe that the majority vote out the good choice. But the question is that in practice it is not. We can see that if a malicious user has managed to occupy more than 1/3 of this block, there's no block can be, or a new attestation can be verified. It can prevent everything. And if this number is far beyond two of the thirds, he can decide everything because himself it is the majority. And actually, even if it doesn't reach the threshold of like 1/3, it can still like attack or steal the tokens we need that with very small slash risk. So that is the potential risk. And actually, we have seen recent such kind of instance in MEV, but mostly it is because of some programming bugs. But
Can other people say what disadvantages they see in these areas? Which you like? I started off on modularity, but
I'm not too sure.
What limitations then do you see in zero knowledge?
I guess from my side, I'm more of like developer using different protocols, but all of them have slightly different implementations. There are too many implementations of the same thing, and sometimes someone forgets something, and it's very hard to audit all the tools to make sure that what you're using is actually secure. Because imagine there's at least 5 different proven systems, and then there are also different commitment schemes, and you can, as you said, do modular combinations of this in different ways, and everyone decides to build, like most of people decide to build their own stuff because they can do it better. But then actually, it's not like I'm not sure if everyone did the good audits of that, like very thorough audits. So it's a bit like as a developer, I'm a bit unconfident about the tools right now.
Right.
What I'm using. I'll put this way. For example, there was a perfect talk about simulation extractability, and that's, for example, some tools just forgot to add a few lines, and then that's what happens.
Yeah.
I think that's really a steep learning curve. But something that's really encouraging is that if you look at events like ZK Hack and ZK Summit that happened 2 weeks ago, but a personal observation I have is that there's a lot of new developers coming to the space from different backgrounds. So some just fresh out of college and some with like more than 10 years of experience jumping into ZK because they think that this is a very valuable field. And a lot of developers are not afraid of the learning curve, and I think that's fantastic. There is a lot of chaos, I would say, chaos in terms of lack of documentation, lack of good tutorials and stuff like that. I think an organization that's really helpful in this space is 0x Park, which organizes workshops, summits, and online sort of like guided classes. They've done a few of those. Definitely check them out.
I want to say a few things. I mean, precisely, I think this field is extremely exciting. There's a quantity of things to learn and explore that is maybe unheard of. The thing is, as more people like come into the field, we also need to make sure that they understand what the assumptions are on some of these proof systems, on some of these commitment systems, so that they can use them in a secure way. Because many times, as you said, they come from different fields. Maybe they don't have a mathematics background or they don't have a computer science background. And if we do not state clearly, here we are making this assumption about the security of this protocol when we use it in combination with this, and so on and so forth, maybe people start like taking pieces of proof systems from here and here, and then it turns out that the resulting protocol is completely insecure. And we need to make sure that the tools we are building are just secure for everybody to use, and everybody understands what the security assumptions are.
On that point, there's zkproof.org that try to build standards around zero knowledge. Do you have experience? Do you follow these? Do you have experience of these? I don't know how widely used these are.
I think it's really early, and standardization is difficult and lengthy. But they do a fantastic job of bringing people together. Yeah. I've seen the output of those conferences. It's very interesting. Just a general point is that I think we are precisely because we are early, the narrative in the public hasn't been set yet. So, as an example, the narrative of crypto today is not so good because you had a lot of things happen last year where it's now associated with negative things like in the past it was like black market, and today it's associated with scams. But we have not seen this with ZK. We have not seen a narrative trend emerge for ZK in the general public, which is a good opportunity because if you just talk to any person who's not a technologist about what is zero knowledge, it's very intuitive that they see that this technology can protect privacy. And I think that's fantastic because everybody knows that the traditional system has failed in protecting people's privacy. If you go to the US, like your social security number is already on the dark web. Or like you can type in your name and find your address and the 5 addresses you lived in previously. So people know that their privacy is not protected in traditional systems, and this we need to leverage this moment to establish a strong positive narrative around ZK. Yes.
And you said about the areas that are important. I think right now already with what we have like 80% of what we can use to do a lot of the first like tier of ecosystem expansion. But going forwards from there, a very big important topic is shared computation, like or shared state, etc. So for example, and you know you've got stuff like homomorphic encryption and MPC, etc. as techniques, and how do these techniques fit together? So one thing I have a design for is anonymous liquidation engine. So if you're trading derivatives with people and you have a position, then when your position gets liquidated, the platform needs to be able to know that info so that it can be able to claim back your position so that it can build this insurance fund, which actually is a protection against going insolvent. So you can't do that with just purely ZK right now. You need to add in some other techniques. Like one way you could do it is you could say, oh, you know, every position has a bond and there's an incentive when you get liquidated to release your bond, but then that's capital inefficient. And so then that's when you start thinking about things like MPC or shared execution. And a lot of now there's an interest in delegated proving so that you could have, for example, mobile phones. And the way that it does that is basically with MPC, like additions are free, but multiplications are expensive. So all it does is it uses these algorithms which minimizes all the multiplications to like one step or a minimal number of steps, and it performs the addition on the servers, and then it sends back the result to the wallet, and the wallet does the multiplications and sends that back, and the servers finish the computation.
In terms of the other sort of technologies that we could link with, what do people want to see? What would you like to? I mean, you mentioned some there. What other things would people like to see? Sort of FHE or multi-party computation, or?
I mean, if FHE becomes usable, that would be amazing. Yeah. But wait, was it Sunscreen or they're building this? So hopefully they'll be quite successful. But again, their biggest hurdle right now is zero knowledge proofs. So again, getting more efficient there would be very important. And I think this delegated proving is actually one of the key ones, because it's hard to imagine that every phone will have a hardware specific for ZK proving. So it will be a lot better if special servers somewhere have that, and then your phone just sends it to these servers with the special hardware and does the job. I would like, not on the technology side, but in general, I would really like to see a lot more collaboration between the projects, because again, the space is very new, and it's very important that it stays safe and secure, and there are no big vulnerabilities discovered after the protocols are deployed. So there was a collaboration between Scroll and Polygon Hermes, for example, trying to educate auditors, and that was a great idea what they did, because like it's projects joined together to make sure that what they're building and the grand vision is going to be secure.
Yeah, makes sense. Ignacio,
yeah, for me as well, maybe not on the technology side, but maybe more what I'd like to see in the future. I think everything is kind of a trade-off. You're essentially always in the dilemma between the efficiency of your protocol and the security of the proof system and the parameters you're choosing. For transparent proof systems, for example, this conflict is essentially between the security of your protocol and the verifier time. And I think what I'd like to see in the future is this conflict being resolved in favor of security, actually.
Yeah. Okay. I think we're coming close to the end. Shall I open it up to questions now, if people have any questions for the panel? please go ahead. You have a microphone.
Sorry, lame question, I think. So try to put yourself in the view of both the user who currently uses Ethereum or any of the L2s and who cares about their privacy, and in protocol developer who's deployed something on one of the L2s and cares about the privacy of their users, which currently is obviously horrible at Ethereum, admittedly. So what would you recommend, such kind of people to look at, like the emergent, technologies, whether that's L2s or development toolkits for the, for the protocol author or, for the user, anything that kind of catches your attention that's worth exploring, and feel free to pick just one of these positions. Amir, obviously, you would, pick DarkFi.
No, I'm not saying DarkFi specifically, but I'm saying crypto is very scammy and corrupted. A lot of these VC funds, they are beneficiaries of the Cantillon effect, where the central bank prints money and they LP it into these big funds, and they have a checkbox. Like, when you're in school and there were kids that got A's on all the exams, but they weren't particularly smart. And they go like, shiny website, check. Big team, check. Web shit, Electron GUI, check. But then you dig the fundamentals of the tech and there's nothing there. And a lot of these funds, they invested at overinflated valuations at the peak of hype mania last cycle, and then got burnt, like when these projects went nowhere and their founders have like 24 million mansion in Lisbon and a private jet. So don't look at the mirage of where everyone's looking. Look for teams that have a strong culture, that they have an idea or a vision of what they're doing, because small teams are like one good dev is better than 20 shit devs. So that's what you have to look for, is find those corners where they exist in crypto, but they're not the people that are competing to get the money, who know how to trick people, trick the big corporate.
Anyone else to?
I guess, yeah, for me, as a developer, if you just want to integrate with something already working, and that's probably the best approach for you, just, again, Google what you want and or ask one of the experts, and we'll suggest you exactly what you need for the use case, because there's Semicloak and other good solutions which you can just plug and play, and you don't need to do any ZK, and that's actually good for you because you can, if you mess up, that's very bad. If you're more hardcore, yeah, like find languages. There are actually about 12 languages. The good to start is usually Circum because it's old and it's been there for a while and you'll understand how it works, but then it depends how hardcore you can get. You can go to Hello 2 or you can go to full-fledged solutions like, again, Noir and all these fancy languages that just try to abstract it as much as they can.
Okay. Probably got time for just a quick question. Oh, no?
Yeah. One more question.
So I think that one of the reasons why there was such an enormous productivity in the crypto space nearly a decade ago, that the cryptographic toolbox have just boiled down to these two primitives, the hash function and the digital signature, that you need to trust, and everything else can be built on top of those, and we got like marvelous things like Ethereum. And the ZK technology seems to be flowering with primitives, like we have range proofs, we have membership proofs, and so on. And there's always this problem that even though we have some universal primitives, but they're not really efficient, and somebody clever always comes up with something specialized that does it much cheaper and better. And do you think that there's a way out of this forest, and we're going to see some crystallization into some small set of primitives that people can trust, and then people who don't even understand those primitives in depth but know what they actually achieve can build on top of those?
No, we should go in the opposite direction. It's actually a good thing. It's the architectural level where we need to put the focus, not on the a cryptographic algorithmic level, because they have trade-offs, and it's not good. Like, for example, even now there's like functional encryption. So there's a lot of really interesting things with that. It's, for example, that you can create these encrypted field elements, and you can only perform one function on those encrypted elements to get a result that is decrypted to a key. So, but then, and that uses a number of different, like, I mean, there's different constructions, but one I was looking at uses a number of mathematical techniques, but even those techniques are modular, and so you can use them in different.
Sorry, we're going to have to finish, but please, everybody, thank the panel.